All right, I just wanted to drop a couple of hints in terms of solving this FRQ for tonight so you're not spending too much time on it. We talked in class about the fact that the dart has angular momentum in terms of the dart bar system. If you consider the fact that the dart is not passing through the center, this offset distance r here is what gives it angular momentum. So the equation for angular momentum of a point mass is r mv sine theta, okay? And at the point of, you know, at the point of contact right here, right before the dart hits, the angle theta between the velocity vector and the distance r, right? That is considered a vector as well. That angle in between those is 90 degrees, right? That's your theta distance, and sine of 90 is 1. So this equation simplifies to r m v. So the dart does give angular momentum to the system. Uh, there is conservation of angular momentum in the dart bar system. Now, just to review, conservation of angular momentum would suggest that there is no net torque acting on the system by an external force. Okay, so if we talk about the fact that angular momentum, which is L, right, it changes when a torque is applied for a certain amount of time, we can try to figure out if angular momentum is conserved or not, right? So angular momentum could be from a rotating body, I omega, or it could be from a point mass traveling a certain distance away from the point of rotation, L r m v sine theta. So going back to our FRQ, right? Say, is angular momentum conserved? Well, we have L initial angular momentum plus torque delta T equals final angular momentum. Well, the question is there a torque acting on the system before and after this crash, an external torque? Well, there's an external force provided by the axle, right? As the dart, when the dart hits, the axle would prevent the system, the dart bar system, from moving downward by providing an upward force, the force of the axle right here. But that does not provide a torque because it is at the point of rotation. So it turns out there is no external force that creates a torque. There's an external force, which is the axle, but it does not create a torque because it passes right through the center. So the distance r is essentially 0. So the initial angular momentum of the dart, right, should be equal to the final angular momentum of the system. Now I want to point out that the dart at this point will be embedded inside the bar, and they will move around at the same final angular velocity, right? And there's a relationship, obviously, between angular velocity and tangential velocity v. But you can see that they both have the same angular velocity. So when you're doing, the final velocity part of the equation, even though there are two components, one from the dart, one from the bar, the one thing they have in common is they have the same omega final. So keep that in mind when you're doing your derivation.